Hello everyone, this is Ms. Nelson, and today we are going to begin with Lesson 7.2, Trigonometry, Solving for Side Lengths. Specifically, the learning targets are, I can establish ratios of the original trig functions. I can apply my knowledge of trig functions to solve for an unknown side length. So let's begin. So first of all, we are going to solve for unknown side lengths, specifically in a right triangle. For example, when we have one missing side of a right triangle, it's important to remember that we can always use the Pythagorean theorem. For example, with the Pythagorean theorem, we know that our hypotenuse is labeled C. We know that our legs of the right triangle are labeled A and B. Using the Pythagorean theorem, we can state that A squared plus B squared is equal to C squared. Then all we need to do is substitute in our values for A, B, and C. A is 3 squared, B would be 7 squared, and C is our unknown side length, so we'll label that x squared. And all we need to do is simplify. For example, 3 squared is 9, 7 squared is 49, that is equal to x squared. We will continue to simplify. 9 plus 49 is 58. 58 is equal to x squared. If we want to get x all by itself, we'll take the square root of both sides. And when we do so, x is equal to the square root of 58. However, when we are working with a right triangle and we are missing two side lengths and we want to solve for a side length, we need to use trigonometry. In prior lessons, we talked about the trig functions, sine, cosine, and tangent. For example, sine is represented by the opposite over the hypotenuse. Cosine is represented by the adjacent over the hypotenuse. And tangent ratio is represented by the opposite over adjacent. So the first thing we're going to need to do is take a look at our reference angle. In this case, our reference angle is 37 degrees. In previous lessons, we learned how to label a right triangle based on the reference angle. For example, if this is our reference angle, 37 degrees, our opposite side would be 37. Our hypotenuse is the longest side of the right triangle, and then the other remaining side next to 37 degrees, our reference angle, would be our adjacent side. At this point, we now have enough information to set up our trig function. For example, I notice that I have my opposite side and I have my hypotenuse. So I'm going to use the trig function sine. So I will write sine of the angle measure, 37 degrees, is equal to opposite over hypotenuse, or 37 over my unknown x. Now I just need to solve for x. First, we're going to get rid of my x in the denominator. The best thing to do is to multiply both sides by the denominator. In this case, that is x. And doing so allows us to cancel x in that denominator. And we are left with x times the sine of 37 is equal to 37. Finally, to get x by itself, we are going to divide both sides by the sine of 37. Here, we're simply undoing the multiplication that's taking place by dividing. At this point, we're simply going to cancel our sine of 37, and we're left with x is equal to 37 divided by the sine of 37. To solve for this, we need to go into our calculator. And in our calculator, we are going to type 37 divided by the sine of 37 and press enter. As a result, I get 61.48 and so on and so forth. Let's round to the nearest tenth, so we'll have 61.5. Going back to our problem, our answer was 61.5. That is the length of our own unknown side. Let's consider two more examples. So first, remember that we do need to write down our trig functions, sine, cosine, and tangent, and their ratios, SOHCAHTOA. And then we're going to look at our reference angle. In this case, our reference angle measures 37 degrees. I then notice that 16 represents my hypotenuse because it's across from the right angle. And finally, the side that measures x is adjacent to my reference angle. So looking at this, I'm noticing that I'm going to use the cosine function because I have my adjacent side and my hypotenuse side. So to begin this, I will write cosine of 37 is equal to a over h, or x over 16. Again, I want to get x by itself and solve for x, so I'm going to multiply both sides by the denominator. In this case, my denominator is 16. I will multiply both sides by 16. And doing so allows me to cancel the denominator, and I am left with x is equal to 12.8 when you use your calculator. Let's take a look at one last example. Again, we're going to take a look at our reference angle, and that is 23 degrees, and we're going to label our right triangle based on that reference angle. I notice that opposite of my reference angle is x, my unknown, and 11 represents the side that's adjacent to the reference angle. Here, I'm noticing I'm going to use the tan ratio. Tangent equals opposite over adjacent. So I will write this as tan of 23 is equal to O over A, x over 11. Again, I'm trying to get x by itself, so I'm going to multiply both sides by the denominator. Doing so will allow me to cancel my 11s, and I'm left with x is equal to 11 times the tan of 23. And for one last example of how to use the calculator, we'll simply type in 11 times the tan of 23 and press enter. And we get 4.66922, so on and so forth. The directions told us to round to the nearest tenth, so we will write 4.7. So going back to our work, we will write our answer, x is equal to 4.7. And there you have it.